Hello everyone, this is Chaz. This is my presentation. My topic was on the contributions of the aerobic system, anaerobic glycolytic system to repeat sprint ability. The title of the article that I chose to review and relate to this particular topic is titled The Relationship Among Repeat Sprint Test Aerobic Fitness and Anaerobic Fitness in Elite Adolescent Soccer Players. So what we're going to go over in this order pretty much is a review of repeat sprint ability. We're going to define it, give some examples as to what it might look like, talk about the bioenergetics of it briefly, and then give some examples as to what training for each of these bioenergy pathways might look like. Then we're going to go into the study that I chose, okay, and look at to see what kind of evidence exists concerning the contribution of aerobic, anaerobic glycolytic, and the PCR pathways to repeat sprint ability. And what I liked about this study is its use of popularly used tests of each of the different pathways, and then how it correlates performance on these tests with repeat sprint test protocols. Okay, so what is repeat sprint ability? Well, it's the ability to produce the best possible average sprint performance over a series of sprints. And below here, I've just included an example as to what repeat sprint events and activities look like, how they're typically characterized, and they're characterized as bouts of activity that last less than 10 seconds. It's probably maybe about 20 reps, those activities, and this short recovery period, which is typically less than 60 seconds. Next, going to how do we typically evaluate repeat sprint ability? And one of the most accepted and accurate ways is called performance decrement. Okay, the performance decrement score. And how we calculate that is we take the total amount of time spent sprinting, then we divide it by the ideal time for each sprint performance, each sprint bout, subtract by 1, multiply by 100, and then that's how we get our performance decrement. And that makes more sense, because maybe the ideal time is 95% of your maximal sprint bout. Okay, and then we want to see how your performance decreases in relation to that ideal time. Okay, so what are the bioenergetics of repeat sprint ability? Well, it's complicated and it's impacted by many factors, but we can say that PCR utilization and availability is a significant limiting factor. And then the energy systems that are responsible for PCR utilization and availability are the aerobic system, which is responsible for the resynthesization of PCR during recovery periods. This is especially true for recovery periods up to 1 minute. Then we have the anaerobic glycolytic pathway, which is responsible for effective utilization of PCR. And about 40% of ATP comes from this pathway initially during a repeat sprint performance. And PCR again is capable of replenishing ATP, the ATP that's used to do work at the fastest rate possible. Okay, so we know what repeat sprint ability is, and we know some of the bioenergetics that makes maximal repeat sprint ability possible. Okay, we talked about PCR, and with all that comes training implications. Okay, two main considerations of training for repeat sprint ability is the intensity of the work intervals and the work to rest ratio, okay, which is basically just looking at how long do you spend working in relationship to how long do you spend resting. Now, intensity gets very vague, and that's when things get confusing because intensity in the literature is measured in many different ways. And we see two different ways it's measured here. We see 100% VO2 max. We see 120% to 140% lactate threshold. In some other areas in the literature is measured as a percentage of one's maximal sprint ability, so maximal power ability, which would seem like it makes more sense. But again, there's some limitations in all this, and it's what makes repeat sprint ability research difficult to produce, but not only that, but reproduce and also to implement. Well, the overall aim and agenda of this study is to examine relationships between aerobic fitness using estimated VO2 max obtained from a 20-meter shuttle test, okay, which is considered a strong, valid, and reliable indicator of aerobic fitness. Anaerobic glycolytic ability using the Wingate, which is considered a reliable and valid indicator of anaerobic fitness, anaerobic PCR pathways using max sprint times, and then finally repeat sprint ability, which will be measured by 2 repeat sprint tests developed by the researchers of this particular study. So the statistical analysis that was used on these variables were Pearson correlation, and that was computed between peak VO2 max, Wingate, and performance decrement scores for a repeat sprint protocol of 12 by 20 meters, and then a repeat sprint protocol of 6 by 40 meters. Okay, so Pearson correlation was run between all of those measures. And we're going to go and look at what they found when they did that. Briefly about the methods, the repeat sprint protocols used in this study were a short and long one. The short was 12 by 20, the long was 6 by 40, and the performance decrement scores of each of those protocols were correlated with one of the following 3: estimated peak VO2, they were correlated with Wingate test results of the population, and they were correlated with the population's max sprint times. So what were the findings of this study? Well, with regards to the long repeat sprint test protocol, they did not find any correlations between the performance decrement scores of that and peak VO2. And this here is just giving you an idea as to how that protocol was run. 6 repetitions, 40 meters, 5 seconds, 30 seconds between reps, and 1:6 work to rest ratio. They did, however, find a significant correlation between performance decrements in the short repeat sprint test protocol and peak VO2. Okay, and again, this here is a brief example as to what they did. It's 12 repetitions, 20 meters, work time 3.5 seconds, recovery between reps about 20 seconds, and work to rest ratio about 1:5. Okay, and towards the end of the presentation, after we look at what the findings were, we're going to kind of talk about what we think these findings mean. Okay, so now let's kind of talk a little bit deeper into the findings, and let's start with aerobic contributions. Now, why did they find a correlation between one of these repeat sprint test protocols and not the other? Why did they find a correlation between the short sprint protocol and not the long one? Okay, because if we were looking at these protocols from a bioenergetics perspective, you may argue that there really is no significant difference between these protocols. And if we were looking at this from a bioenergetics perspective, we would be focused on time spent working per effort. Okay, we would look at the differences between the 2 protocols in that area, the intensity of each effort, the work to rest ratio, and the length of the recovery periods. Okay, and we would be thinking about the recovery periods, keeping in mind that bouts of activity or bouts of rest, up to 1 minute is heavily dependent on the aerobic system. So, and when we look at that, what do we see? 30 seconds for the long sprint protocol and 20 seconds for the short. That doesn't appear to be a big difference, and it's still under 1 minute. So again, there doesn't appear to be a significant surface on the surface of these protocols. Yet one was correlated with VO2 max and the other was not. But what we do see, though, is maximal sprints occurring over 6 reps versus 12 reps. So that's a large difference. And so it may be the answer as to why only one of these protocols were physiologically related to aerobic fitness. There may be a correlation between the number of sprints performed and, again, whether or not aerobic fitness and capacity is going to be a significant contributor to the performance of a protocol such as that, a protocol with high volume reps. So what evidence, if any, were there of anaerobic glycolytic contributions to repeat sprint ability? Okay, well, in this study, they used the Wingate as a measure of anaerobic glycolytic ability. Okay, and Wingate typically gives us peak power, mean power, and fatigue index. And this is important to measure because, in theory, these are the measurables that repeat sprint test protocols are trying to give us. Okay, we want to know what the max sprint was. Okay, so our peak power, our peak performance. We want to know what the average sprint performance was. Okay, so our mean power, mean intensity. And then we want to some kind of measure of fatigue, and that's where the performance decrement score comes in. So we see the similarities there. Now, however, despite these similarities, and despite the fact that from a bioenergetics perspective, Wingate appears to be measuring the same things as repeat sprint measurables, there was no correlation found between the performance decrement scores of RST protocols and Wingate test results. And this can be explained, the researchers attempted to explain it, and they said this could be due to the fact of the amount of muscle used, or differences in the amount of muscle used between the protocols, and the number of repetitions performed and the recovery time between those repetitions. Now, as far as amount of muscle used, let's talk about that first, why that may play a role. So Wingate would be measuring the ability or your ability to perform repeat anaerobic bursts of energy in more localized areas of muscle, whereas repeat sprinting tests measure repeat anaerobic burst of energy ability across large muscle cross-sectional area. Okay, so a more global area of muscle. So even if the work times and the rest intervals of both testing protocols appear to be the same or appear to be bioenergetically similar, fatigue measures will be different. Simply because of the fact that one is measuring local fatigue and the others measuring more global fatigue. Now, what evidence of PCR contribution to repeat sprintability did they find? Well, there was a significant correlation between fastest sprint times and low performance decrement scores seen for both repeat sprint test protocols. Okay, and we would expect to find that, okay, since PCR is identified as the limiting factor for repeat sprint ability, mainly due to the fact that PCR is capable of replenishing and synthesizing ATP at the fastest rate possible. ATP we use to do work, and if we need to do work at a very fast rate, such as during a fast sprint or maximal sprint, well, then we need to be able to effectively utilize PCR. Well, some strengths of this study, and I'm glad they did this. They said that they used 2 different repeat sprint tests on the same group of players. Now, they said they were the first to do this, and I thought that was interesting because this is a 2009 article, and that just seems like something that would have been done by 2009. But why this was a strength is because it allowed for them to look at the relevance of each repeat sprint test protocol to different physiological and performance measures. So if I have athlete A, okay, and I take 3 different performance measurables from him, and I relate them to one protocol, and I see no correlations, but I relate them to another, and I do see correlations. Saying, well, on the surface, those protocols may not look different, but that would spur further investigation. Like, okay, well, they don't look different, and they don't, in theory, they don't seem different from a bioenergetics perspective, but they must be different. So I thought that was a strength of this study. Well, everyone, that concludes my presentation of my review of this study. Hope you picked up some new insights on that, and thank you for listening, and see you later.